Alabama, and I'm working on the project Measuring Risk Attitudes in the Lab with Dr. Paan Jindapon. A brief overview of our project before I give a more formal layout of this presentation is our objectives. We are working to measure higher order of risks, and we're going to do that by building off of and expanding upon the Holt and Laury model for eliciting risk preference. And then we're going to explain how does changing higher order risks impact decision making. I am first going to start by giving a background of statistics, which is going to tie into the Holt and Laury model and explain what exactly that is, before I detail what are higher orders of risks and how we're going to measure them using Qualtrics. Since we're running this in the TIDE lab, I'll give a brief overview of the IRB and then detail next steps as we continue the project into the spring. As for statistics, there are probability distribution functions, which you can see on the screen. On the left, you have a standard normal curve, and on the right, there is a gamma distribution with parameters alpha equals 2 and beta equals 2. The vertical lines are representative of the expected value. The expected value is one of the tools we can use to measure risks, and it is the best guess for the outcome of an uncertain event if you ran an infinite number of times. We also care about variance, skew, and kurtosis. Variance is how we measure risk aversion, and it explains or is an analytical tool used to determine the spread. How far apart are the values from the expected value? We also care about the skew, which is a measure of symmetry. As you can see in these distributions, you have zero skew for the normal curve because it's perfectly symmetrical about the expected value. As for the gamma distribution, you have a positive or right skew because more of the distribution function is to the right or the positive side of the expected value. It should also be noted the median is greater than the expected value. We also care about kurtosis, which is the fourth tool we're going to be using to measure things, and that is a detail of how heavy are the tails. A tail is the probability distribution function as it goes to negative infinity or infinity. So higher kurtosis implies more weight in the tails as opposed to being clustered around the expected value. And we use this when we come to the Holt and Laury model, because the Holt and Laury model is a two-lottery system that we use to measure variance and see how do people respond to changes in it. The basic example is two lotteries with the one on the left and one on the right, as we have here. You have a 10% chance of winning $2 or a 90% chance of winning $1.60. You also could have the option instead to have a 10% chance of winning $3.85 or a 90% chance of winning 10 cents. Most people in this case will choose the one on the left because of the higher expected value. However, we will change those probabilities and to an 80% and 20% chance. And while the one on the right may be more appealing than it was earlier, most people will still choose the lottery on the left. We continue to change those probabilities, and we arrive at a point like this, where the one on the left is $1.76 for the expected value, and $1.60 expected value for the one on the right. But as soon as those probabilities change to a 50-50 split, the expected value also switches. The expected value for the one on the left is $1.80, and the expected value for the one on the right is $1.97.5. And at this point, you might expect people to switch. However, some people may be scared off by the downside of the chance of winning only 10 cents and stick with the one on the left. That is why we continue this until we have a 90-10 split in the opposite direction as we started. We do not necessarily care if people switch, but more so when do they switch, because that tells us more about at what point are they willing to trade expected value for a variance. And so that brings us into our higher orders of risk, because with the Holt and Laury, we are confined to measuring risk aversion and risk lovingness. But we care more about prudence and temperance in this study. And we measure prudence using skew, similar to how risk aversion is measured with variance. Likewise, temperance is measured with kurtosis. And a brief overview of how we do this using the simple variance case is what we have here, where we have 4 options to choose from. If we break it into 2 pairs, we have a plus 2 and 0. In this case, the blue plus 2 is positive because we want higher numbers, and 2 is greater than 0. However, we also should note that in the other pair, the 0 is greater than negative 2. In this case, the 0 is the one that is good, and the negative 2 is the one that would be bad. When given the option, as we can see in the graphs below, you can either put good and good and bad, like the graph on the right, or good and bad and good, as the graph on the left. Both of them have the same expected value, but they have different variances. If you choose the one on the left, that implies that you are probably more likely to be risk averse than someone who would choose the one on the left with the higher variance and the same expected value. As such, we have designed our own surveys in Qualtrics using HTML and C# among other coding languages to be able to create a more refined approach to what we are doing. We will be able to drag and drop these options into here. It should be noted that they're options because we may make these into compound lotteries, where the option can be either a number and make this a simple lottery, or it could be a lottery within itself as the option. Therefore, we would have lotteries within the lotteries, which would make it a compound lottery. We also are planning to portray it in a different way. This is effectively the same mathematical lottery. However, we are displaying differently in order to see, does the subject better understand this, and does the representation of something impact how prudent and temperate someone is. This has the same drag and drop features as previously noted in the other representation. We also plan to run the experiment that we had at the beginning to see, measure people's variance, how do they care about variance, and is there a correlation between risk loving and risk aversion to prudence and temperance. And since we are running this experiment through the TIDE lab, we had to get certified through the city program, and we did that earlier this semester. We will then have to draft our project experiment and submit it to the Institutional Review Board, which gives us the either approval or denial, and we will work on it until we can get approval for our project. And I guess the overall question is, why exactly does this matter? And what information do we gain? We really care about how exactly does prudence and temperance affect people's decision makings. We hope to better be able to predict how they impact, and also to what extent are people prudent, in addition to simply are they prudent or are they temperate. And we hope to be able to expand this questioning. Does anyone have any questions?
I'm curious about whether you're collecting the demographics of your participants from age, gender, maybe even socioeconomic status, or results of a personality test, something like that. Is that part of any of this? And if so, or if it could be a future work, do you have any kind of insights into what differences might come across from, say, difference between genders?
Yes, we plan to gather some of this demographic information. Of course, we are limited to some extent by the Institutional Review Board, but we would like to gather as much information as we can so we can create the most precise results as possible.
I'm just curious what results you expect to find, and if you think people will be more prudent.
Yes, this is actually interesting because when you look at previous results, you actually see that people are more likely to be prudent than they are to be risk averse. And so we expect people to be prudent, and our study is more of an emphasis on to what extent in addition to that, because we can somewhat guess that, but we care how prudent are people, how temperate are people.
Okay, so I want to hear a little bit more about which specific data analysis tools you're going to use and what your methodology might look like.
Yes, we have all of our data stored in embedded data, and we're exporting it to Excel, where we'll probably use other tools like R in order to analyze the data. We plan to use both parametric and non-parametric ways of analyzing the data, and we will do this because we care about how do people rank against each other, while also being able to make more predictions about how future people, independent of the ones in our study, would be able to react.